In this lecture, let us discuss about software maintenance, which is a process of updating, improving, and fixing the software after its initial release. This phase ensures that the software continues to meet user needs, remains secure, and functions correctly over time. Maintenance activities are typically required to address issues like fixing bugs, updating software to comply with new requirements, or to optimize the performance, or for enhancing security and to address a performance degradation issue or to find out changes in the user requirements. And the models which comes under this software maintenance are first is a quick fix model, which refers to a maintenance strategy where the focus is on rapidly addressing and fixing critical issues like bugs, errors, or security vulnerabilities with minimal changes to the system. So it won't dive deeply into the underlying system design or structure. This approach is often used in scenarios where immediate solutions are necessary and the fixes are relatively small and straightforward. And these are even required to address defects or failures that significantly impacts users or business operations. So whenever a problem is found, then that problem will be fixed and then it will search for other problems. So the goal is to quickly resolve urgent issues that affect the functionality or stability of the software. For example, fixing security, vulnerability, system crashes, or critical bug that impacts the users. And here the fix is typically small in scope and does not involve large scale changes to the software. It's more about patching or tweaking the system rather than re-engineering or refactoring the code. Coming to the key characteristics of quick fix model, first one is speed over perfection. The goal is to quickly resolve urgent issues that affect the functionality or stability of the software. For example, fixing a security vulnerability, system crashes, or a critical bug that impacts users. Second one is temporary or short term solution. In many cases, quick fixes are seen as temporary measures. They may address the immediate issue but are not intended to provide a long term solution. This could be due to time constraints or the need for a more thorough solution later. Minimal changes. The fix is typically small in scope and does not involve large scale changes to the software. It's more about patching the system rather than re engineering or refactoring the code. Risk of introducing new problems. By making changes to the existing system, there may be chances for introducing new problems later in the system. Coming to the steps in quick fix model, it involves series of steps focused on resolving urgent issues rapidly and with minimal disruption to the system. And the first one is identify the problem or problem identification, which means quickly diagnose the issue typically based on user reports, logs, or monitoring tools. So identify the issue that needs immediate resolution. And then temporary patch development. Apply the fix to the software typically with minimal changes to avoid introducing new problems. So the main goal of this temporary patch development is to quickly implement a solution to the identified problem. Step 3 is to test the fix. After implementation, we need to go with testing, right? So conduct basic testing to verify that the problem is resolved and that the fix doesn't introduce new issue. So here, ensure that the fix works as intended without causing unintended side effects or failures in other parts of the system. So ensure that the immediate problem is resolved. Then deployment of the fix. Deploy the fix into the production environment, ensuring minimal downtime or disruption to the users. So main aim is to minimize the downtime or service interruptions. Here, implement the fix in a live environment and make it available to the end users as quickly as possible. Then plan for future investigation if necessary. Say if the fix was only a temporary measure, begin planning for a more permanent solution to the problem. ensure that the root cause of the issue is addressed, preventing the need for further quick fixes in the future. Second model is iterative enhancement model, which is a software development and maintenance approach where software is developed and improved in small incremental cycles or iterations. Instead of delivering a complete final product in one go, the model focuses on gradually enhancing the software over time, allowing for frequent releases and continuous improvements based on user feedback, testing, and changing requirements. Here, the software is continuously improved, and that takes place through a series of iterations. So, here, improvement can be either adding the fixes or fixing the defects. So, adding features, fixing defects, or optimizing performance, refining the user experience. So, all of them comes under improvements only, right? Key characteristics of iterative enhancement model include the first one is incremental changes. Software is built in small manageable iterations, each adding new feature or enhancing existing ones. So here each iteration typically results in a working version of the software that can be tested and evaluated by the stakeholders. Then continuous feedback. After every iteration, software is improved based on the feedback from users, testers, or business stakeholders. So, this approach allows for evolving requirements and also for better addressing user needs over time. Flexibility. The model allows for flexibility in changing the requirements. As the software progresses, new features or changes can be incorporated into subsequent iterations. So, this reduces the risk of delivering a product that doesn't fully align with user expectations or business goals. Next is frequent releases. At the end of every iteration, a new version of the software is released, even if it's not fully feature complete. This makes it easier to deliver partial functionality quickly and gather feedback for further refinement. Then risk management. So by delivering the software in multiple iterations, risk can be identified early in the development process, which allows for easier mitigation of issues. Also, the problems they are usually addressed in small, manageable chunks rather than in large or complex releases. Third model is reuse oriented model, which focus on maximizing the use of existing software components, libraries, frameworks, and modules rather than developing new code from scratch. And the idea is to save the time, improve consistency, reduce cost, and also increase the software quality by reusing pre built solutions or modules. It even reduces the redundancy, minimizes the errors, so thus allows the organizations to build new functionality based on the existing software artifacts. Here, the software is composed of existing reusable components that can be integrated to meet specific requirements rather than developing everything from the ground. So, this approach is common in object oriented programming, component based software engineering, and service oriented architectures. So, here you can see the how the component library is reused from old system into the new system. Coming to the key characteristics of reuse oriented model, first one is component based development. Software is often developed using pre-built modular components that can be independently tested, updated, and replaced. These components are mainly designed to be generic and flexible so that they can be used across various projects or systems. Then improved quality. Reused components, they are already well tested, right, in different environments. So as they offer better reliability and performance compared to newly developed code, it actually improves the quality of the new software also. And the quality of the final product benefits from using the mature, stable, and well tested components. Then standardization. By relying on established components and frameworks, software built using this model often follows industry best practices and standards, which leads to more uniform and predictable systems that are easier to maintain. Then reduce development time, or even you can take cost also. So by reusing the existing solutions, developers can save time and effort that would otherwise be spent building code from scratch. Also, it leads to faster delivery of the functional software. At the same time, cost also. So by reusing the existing component, it reduces the development costs since less new code needs to be written. Next, maintenance and upgrades. Reusing the components can simplify maintenance as updates or fixes to the reused component can be applied across multiple systems that use them. So, this actually reduces the duplication of effort for maintenance tasks. Coming to the different phases in the reuse oriented model, first one is component identification. So, here we need to identify and also gather reusable components, which may include libraries, frameworks, and tools that are already available. So the components can come from internal repositories, open source projects, or third party vendors. So, first, we need to identify the software components that are better for reuse. Second step is component selection. So, carefully, we need to evaluate the reusable components to ensure that they meet the requirements of the new project or not. So, it includes various things like compatibility, performance, licensing conditions or considerations, then quality. So, by checking all these things, we need to select the right component. And the third step is integration. Integrate the selected reusable components into the new system, ensuring they work together and meet functional requirements. So it often involves adapting components to fit into the new software architecture. Next is customization and extension. So although the components are reused, they may need to be customized or configured to meet the specific needs of the project. It include modifying, extending the functionality of the existing component or adjusting the settings for the system. And after this, we need to go with the testing, deployment, and ongoing maintenance. So they are common. You need to include them also in phases in the reuse oriented model. And the next model is taught maintenance model, which is mainly used for categorizing and managing the activities involved in the software maintenance. And this is a maintenance strategy which emphasizes tight control over the changes in maintenance activities, ensuring that the system stays as stable as possible with minimal intervention. And this model is often used in environments where stability, security, and reliability are the utmost importance. So, for example, if you take mission critical systems or embedded software or industries with regulatory requirements, for example, healthcare, aerospace, finance. So, in all those cases, security is considered to be the most important factor. Along with that, reliability and stability also. So, in such places, we need this taught maintenance model. And we have different phases here. You can see in the diagram. Okay. So, the requests which are sent by the client will be received during this phase, and usually those requests are sent in a prescribed format. And this request change, it can fall in any category of the maintenance activities. So this change request, it may fall into either corrective, adaptive, preventive, or perfective maintenance activities. After that, so you need to this maintenance team, they should identify in which activity that change request falls into. So identify the category and then assign a unique identification number of the request. Next phase is the estimate phase. Here the team they should focus on estimating the time and effort required to make the requested changes. So the changes which are requested here, in order to implement them, we need some time. So those budget estimations as well as the time estimation will be done during the second phase. And the third step is schedule. So during this stage, the team identifies the change request for the next scheduled release and prepare the documents that are required for planning. Then moving on to this fourth phase, programming phase. So during this programming phase, source code is modified to implement the requested changes. So based on the change request received, code should be modified accordingly. And all relevant documents like design document, manuals, so they should be updated. The final output of this stage is the test version of the source code. So during the testing phase, the modifications and updates required in the software, they are carefully implemented. And also the code is tested using available as well as new test cases. So we can say that regression testing is implemented in this testing phase because here adding these new changes, it should not affect the existing functionality. So in that way, changes should be done. So that can be identified with the help of regression testing. Then coming to the next phase, documentation. After regression testing, system and user documents, they are prepared and updated before they are released into the public. So by doing this, the developers, they are able to manage correlation between the code as well as documents. Then coming to the release phase, the software product along with the updated documents, they are delivered to the customer. So not only the software product, but also the updated documents, they should be released to the customer during this release phase. And acceptance testing is performed by the users of the system. Then moving to operation phase. So once acceptance testing is performed here, software is placed under normal operation. So during usage, when another problem is identified or the new functionality requirement is felt or even the enhancement of the existing capabilities desired, again change request is initiated. So this is a continuous process until the team receives a change request. This process will repeat.